Hey everyone! In this lesson we're going to start something that's a little bit different from what we've been doing in the last couple of videos. In the last couple of videos we've been talking about addition, subtraction, multiplication, and division of fractions, and that's kind of it. We've only been talking about fractions, but fractions are just one way to express portions of a whole number, right? If you've got half of something, you could write that as a fraction, or you could write that as a decimal. So what we're going to talk about in this video is how to convert a fraction to a decimal, and vice versa, and the other way around. How to convert a decimal to a fraction. So that's what today's lesson is going to focus on, it's really not overly complicated. I'll show you basically how it works, and we'll do a couple of examples going in each direction, a couple going from fractions to decimals and a couple going from decimals to fractions. But aside from that, sort of the details of how to do of basically how to convert fractions to decimals, you'll see when we get there. We've kind of already talked about this already. We talked about this back when we were multiplying and dividing with decimal numbers. That stuff is going to come back and be useful when we're trying to convert fractions to decimals and the other way around. But so yeah, I'm going to show you the process that we sort of go through when we're doing these conversions, and you'll see for yourself that there are some things that might be a little bit familiar from what we did at the start of the school year. So if we start by going, actually before I go through the process of converting fractions to decimals or decimals to fractions, I'm just going to write down a few that are handy to just memorize. You can always go and calculate them, and using the methods that I show you, you can go ahead and calculate some of these for yourselves, just as practice. But I'm going to put up a few that it's just handy if you memorize these so that you don't have to calculate them all the time, because these are ones that we'll come across kind of all the time in our daily lives, some of them more often than others, but still useful ones to know. So the first one is, of course, this one up here. 1/2 is equal to 0.5. That's just a useful one to know. If you see any number that ends with 0.5 and that's it, that's, if you're writing that as a fraction, you can express it as 1/2 or 1/2. Same idea with these other ones. If you see something that ends in, for example, if you see something that ends in 0.2, then that means that you've got 1/5 of a whole left over. So here are just some useful ones to know. We'll talk about these a little bit more once I just get them all up on the board. I'll talk about where these ones can be useful as well. Now, of course, if you're looking at a decimal number and you're trying to convert it to a fraction, if it ends in one of these things, in one of these decimal values, then if you've memorized these ones, then it's quite simple to just switch from this one to that and this one to that. The one thing I want to point out before I forget is this line over the 3 here means that this 3 just repeats forever and ever and ever. So if you've got, so the other way that you could write this, if you see this on like a calculator, you might see 0.3 with the line over it, or you might see 0.33333, just an endless string of 3s until your calculator screen is filled up. So that's what that bar on top means. It just means that whatever digits are underneath that bar just repeat forever. But yeah, so these things are all useful values to know, so you could write these down. But here's something, here's like a way where, sort of a situation in which you can use them. We'll start with going from fractions to decimals, because this is kind of, this is useful, I guess maybe more so going from fractions to decimals. So we'll start going in this direction. So fractions to decimals. Now, one way to go from a fractional number to a decimal number is to, if you have a number like, let's say 7, or let's say 0.75, as a decimal, turning that into a fraction, having memorized these numbers, might not work out so well. So what we're going to do instead is we're not going to use these things so much for going from a decimal number to a fraction, but we're going to use them going from fractions to decimals. Now you might be able to express 0.75 as a fraction, but it's probably not because you memorized any of the decimal values or any of the fractions that I've written up on the board. So instead of writing a decimal value and starting with that, we're going to write a fractional value, like let's say 4/5, something like that. And I'm asking you to write 4/5 as a decimal. Now, if you've memorized all of these values down here, then you'll see that we've got one value, one fraction here, one pair of numbers here, where the fraction's denominator is a 5. We know that 1/5 is equal to 0.2, right? That's the information that we've got from this group of 6 things down here. So we know that 1/5 is 0.2. 4/5 is just 4, or 4 over 1, if you will, times 1/5, right? So really, I'm going to write this as just 4. Remember, I don't know if I mentioned this before, but just as a note, if you're multiplying a whole number by a fraction, this whole number is really just a numerator over a denominator of 1. So when you're doing that multiplication, you just multiply the two numerators together and you don't touch the denominator. So I could rewrite 4/5 as 4 times 1/5, right? Because we know if I multiply those numerators together, I'm going to get a 4 on top. 5 stays the same on the bottom. So this is a perfectly valid way to rewrite 4/5. But we know that 1/5 is 0.2. So I can rewrite this as 4 times 0.2. And I can use that to get my decimal answer of 0.8. So basically what I'm trying to say is going from a decimal to a fraction, going from a fraction to a decimal, excuse me. If you've memorized these values down here, then if you've got any fraction where the denominator is 2, you can just multiply this decimal value by whatever the numerator is to convert your answer into a decimal. Same idea with any of those. If you've got 3/4, then that's just 3 of these, 3 1/4 bits. So if 1/4 is 0.25 and 3/4 is 3 times larger than this, then the decimal value must just be 3 times larger than that. So you would just do 0.25 times 3 to get your decimal answer. Alright, hopefully that's making sense. But the second way to go through this doesn't require that you memorize any of these values. And so I'm going to show you that one just because that one works for any fraction. This method only works if you've already memorized what 1 over some specific denominator is as a decimal. Sometimes the decimal won't be a nice one. Sometimes it'll have a whole bunch of digits and then those digits all repeat, or it'll be like an 8-digit decimal, or it gets complicated really fast. There are only some, like a handful of nice ones that we use on a semi-regular basis. And those are the ones that I wrote on the board. There are a couple of others that you might see, like 1/20th or 1/25th or 1/6th or things like that. So there are other ones for sure. But the problem with trying to just find, like if I asked you to figure out 5/6 as a decimal, the problem is, sure, you can break this down into 5 times 1/6, but you need to have memorized what 1/6 is in order to be able to do that multiplication. Now obviously if you're using a calculator, you could just punch in these numbers and it should give you your answer, but the catch of trying to use this sort of breaking down the fraction into a whole number times a fraction, the catch to that is that you need to know how to express that fraction as a decimal, and you just need to know it. It's not that you figure it out because to figure it out, that's the method that I'm about to show you. So let's take a fraction like, let's say 3/5, or 3/5. Alright? Now, if I go by the first method, we're in luck right now because our denominator is a 5. So I could write this as 3 times 1/5, right? This is just 3 groups of 1/5. And if you tried to do this multiplication, 3 times 1/5, that's really 3/1. So if I multiply those numerators together, I'll get a 3. If I multiply those denominators together, I'll get a 5. So this is definitely a valid way to write 3/5 as, in a slightly different form. Now, if you have memorized from past experience, or because I just wrote it on the board, that 1/5 is equal to 0.2, then the easy way that you could solve this is to write 3 times, and we know 1/5 is 0.2, so we write that there, and we just do that multiplication, and we'll get 0.6 as our answer. And that's one way to go about it, but what if you don't know how to express 1/5 as a decimal? Then you run into a little bit of trouble. So, in order to compensate for that, we're going to figure this out using a different method, where it doesn't depend on the denominator being a nice number that we already know tricks for. So, remind yourselves, if you've forgotten, that if you write a fraction like this, 3/5, that's the same thing as 3 divided by 5. Right? That's the exact same thing. What it's saying is that if you had 3 pizzas and you divide it into 5 equal groups, this is a perfectly valid way of expressing that division problem over there. So these two are equivalent. They're just written in slightly different ways. But if I asked you, if we go all the way back to September, when we were just doing multiplication and division with whole numbers, if I asked you to do 14 divided by 7, no problem. If you don't know how to do it, like if you don't already know the answer, you would just go and do the long division. If I asked you to do 15 divided by 7, you would still go and do the long division, and sometimes you'd get a remainder, or other times maybe you'd express it as a decimal, and you'd write down the decimal, you'd move on with your life. Here, it's the same idea. It's still just a division problem. So we're going to set it up like a division problem. So we remember that when we've got that division sign, our dividend, which is this 3, that's going to go under here, and the 5, our divisor, is going to go on the outside. This is the part where people tend to get tripped up because they're used to the larger number being under this division sign, but you have to be careful that if your division problem has a dividend that's smaller than its divisor, then the division problem might look a little bit wonky when you set it up. So make sure that that dividend is going underneath and that this divisor is staying on the outside. Now you go ahead and you try to do the division problem. How many times does 5 go into 3? It doesn't, so if we want, we can put a 0 up there. 5 times 0 is 0. We subtract, we get a 3. We haven't changed anything. That's all optional, you don't have to write that stuff. But now, instead of treating this as just a 3, we make this 3.0, and because this long division now involves a decimal point, we're just going to line up our decimal up there. And so now we're going to treat this as 30. How many times does 5 go into 30? Sorry, we need to bring that 0 down here since I've done that math. So we bring that 0 down, we've got this 30 here, right? How many times does 5 go into 30? It's going to go into 36 times, so we put our 6 up top. 5 times 6 is 30, so we put that here. And we keep doing this process until we've got a 0 as our remainder, which in this case, we got it after the first try. So our final answer would be that 0.6 that's up top, which matches what we got before. So basically, we've already done long division involving decimals. This is just more of the same. It's just I give the question to you in a slightly different form, and I say convert it into a decimal. It's basically the same thing as if we were doing our long division unit, and I just say what's 3 divided by 5, and don't give me a remainder. then you would go through this process and you would tell me, okay, 3 divided by 5 is 0.6. All that's happening is the question is being phrased slightly differently, and I'm saying express the fraction 3 over 5 as a decimal. It's the exact same problem as what's 3 divided by 5, but do the long division problem without remainders and give me a decimal answer. So it's the exact same process as stuff we've done before. We'll do one more example of this so you can sort of see how this works in action, and then we'll switch gears and go from decimals to fractions. So for this one, I'm going to require a little bit more space. So for this one, we're going to do 4 divided by 7. Right? That's what we're going to try to work out. Now, we have to remind ourselves that 4 over 7 means the same thing as this, right? So we've got 4 over 7 as a fraction means the same thing as 4 divided by 7 like that. But if we're doing 4 divided by 7 like that, then we might as well go through the long division. So we're going to set it up as a long division problem. So remember that this 4 over here is our dividend, and this 7 here is our divisor. So remember that your divisor stays on the outside and your dividend goes underneath. Alright, so now we've set this up just fine, and we start the long division problem as we always do. How many times does 7 go into 4? It doesn't, so I'll put a 0 up there, and put a minus sign here, and we subtract 0, because 7 times 0 is 0, and we're left with a 4. Now we need to turn this into a decimal, so we make this 4.0 so that we can bring that 0 down, and now we've got a 40 down here. We go through the same process. How many times does 7 go into 40? It's going to go into 45 times. Remember, we're going to line up our decimal point up there. We put our 5. 7 fives are 35. We subtract. 40 minus 35 is going to leave us with 5. Right? Now, we can put another 0 here, right? That's still 4. I haven't changed it from 4. 4.0 is the same thing, so I put that extra 0 there, bring that down. Now we've got a 50. How many times does 7 go into 50? It's going to go in 7 times. 7 sevens are 49. So we put that downstairs, and we subtract, and that's going to leave us with a 1. And let's do one more digit. This one goes on forever. After you get to past a few decimal places, it just starts to repeat. But let's do one more. We put another 0 here. We bring that 0 down. Now we've got a 10. How many times does 7 go into 10? It's going to go in once, so we put a 1 up there. We subtract 7, and I'm running out of room. But we would be left with, down in that space over there, we'd be left with a 3. And we could keep going. We could keep adding zeros, bringing them down, and working through it. The problem with converting fractions to decimals is sometimes you will get decimals that just go on forever. So you can't keep going until you get a 0 as a remainder, because for some of them, you never will get a 0 as the remainder. And for a number like this, for 4 over 7, when you go through that decimal thing, it's hard to notice when it starts to repeat, and it actually takes, you get 6 decimal places before it repeats. So the full answer, I was working this out earlier, you get 0.571428, and then it repeats. You get 5, 7, 1. So it'll take you a while. You'll be working out 6, 7, 8 decimal places before you notice, hang on, this has started to repeat. I'm going through the same process again. And then, maybe you read the question, it says round to 2 decimal places. You've done all of this extra work, and then you're reporting only that much as your answer, 0.57 or something. So it can be a little bit tricky. If I give you a question like this on the test, I would tell you, and hopefully if I remember, I'll bold it, that if I'm saying convert the following fractions into decimals, only go as far as 2, maybe 3 decimal places, because I don't want you to be working on the same problem for the whole half hour. and then, you know, running out of time for everything else. So that's sort of the catch with going from fractions to decimals, but just doing this long division and just adding more and more zeros here, and just, you know, you just keep going, will eventually get you that answer up top. And that's something that your calculator could spit out if you just typed in 4 over 7 or 4 divided by 7 into your calculator. But long division is really, really handy, as you might have seen. I mean, it's handy to just do division, like of whole numbers. It's handy to get decimal answers for fractions, and it's handy to convert improper fractions into mixed numbers. So it's a really useful tool. And if you're not feeling particularly comfortable with it, I suggest you practice it, not just for the sake of, you know, a test or marks or assignments or anything like that, but just because this kind of stuff is useful. You know, if you're ever in a position where you need to do some division, there's no shame in pulling out, you know, a pen or pencil and a slip of paper and just quickly figuring it out if you don't have a calculator on you. And if you're really, really good at your long division, you'll be able to calculate an answer like this, something that, you know, prior to learning long division looks like something only a calculator could ever be capable of doing. A calculator, a phone, a computer, but not something that you could ever figure out by hand. But it's a really useful tool. Sure, it can be a little bit tedious, it can take up a lot of space. On the whiteboard, obviously I've got limited space, so I ran out of room to do all of those digits, but those digits would all repeat. So if you plug this into a calculator, incidentally, you might find that your calculator tells you 0.571428, and then it'll chop off that 571 that's repeating, and it'll just put a bar over these 6 digits because they repeat forever. So this means that it's 0.571428, 571428, 571, so on, forever. So that's basically how converting fractions to decimals works. And you don't need to know what 1/7 is and then multiply that by 4 or anything like that. Just do long division, dividend, divisor, numerator, denominator. Just make sure you don't get the placement of the numbers mixed up, and you should be fine. Now we'll go the other way. We'll go from decimals to fractions. So I'm going to get rid of this problem. And if you want to rewrite a new heading under this example that we've just done, you can write decimals to fractions. I'm feeling a little bit lazy, so I'm just going to switch the direction of the arrow, and we're going to go from there. Now, with decimals to fractions, it's quite simple. There's one thing I will point out a little bit later, but we'll start with a relatively simple example. So we'll take 0.725 as our decimal, and I want you to express this as a fraction. So here's the way you do it. So we know it's going to be a fraction, so let's put that line for our fraction. Now, the numerator is just going to be all of the digits that I've given you after the decimal point, only after. We don't care about this 0 out in front right now. In an example or two, we'll talk about what happens when this number isn't a 0. So we're just going to take those digits after the decimal point, and we're just going to throw them into our numerator. Alright, so we've got 725 as our numerator. That's come from the 0.725 over here in the question. Now for your denominator, there are 2 ways to think about it. The first, and potentially more confusing way to think about it, is that if you remember your place values, you know, you've got like a number in the hundreds place, and the tens place, and the ones place. This 7 is in the tenths place. This 2 is in the hundredths place, and this 5 is in the thousandths place. So since the smallest number we're dealing with is in the thousandths place, we're going to ignore that th, and we've got the number, we've got the word thousand here. And so because we've got the word thousand there, that's going to tell us that our denominator should be 1000. The other way you can think about it, I don't really like thinking about it that way. The way I like to think about it is your numerator is just the digits that are after the decimal point. We've dealt with that. In your denominator, you're going to throw a 1, and then you're going to put some number of zeros. And the number of zeros that you put is actually dictated by how many digits you have after the decimal point. So here we've got 1, 2, 3 digits after the decimal point. 7, 2, 5. 3 digits after the decimal point, so we're going to put 3 zeros. And so we've got a denominator of 1,000. So that's two ways that you can think about it. If the last digit that you were given was in the hundredths place, then you'd put 100 as your denominator. If your last digit was in the millionths place, then your denominator would be 1 million. So now we've converted this fraction, or this decimal, into a fraction over there. The only thing that's left now is to reduce. And so you can reduce this in steps. You don't have to reduce all in one go. So I have a hunch that since this ends in a 25 up top, and this down here is divisible by 25, I have a hunch that this thing is going to be divisible by 25. But let's say you don't notice that, and let's say you just choose to divide both of them by 5, since, you know, you can see very easily this ends in a 5, so it's going to be divisible by 5. This ends in a 0, so it's going to be divisible by 5. So if you go through and figure that out, you should get, I believe it's 145, but let's go through the long division since we know how to do that. So we put, that should be a 5. So we're dividing that numerator by 5. It goes into 7 once, subtract 5, it's going to leave us with a 2, bring down a 2, it goes 4 times, minus 20, leaves us with a 2, 5, yeah, 145 is going to be our new numerator. So we've got 145 over, and then our 1,000 divided by 5 is going to give us 200. Now that still is two numbers that are divisible by 5. So if we divide them both by 5 again, then that should get us closer to a final answer. Now 145 divided by 5, let's see, 100 divided by 5 would be 20, and 45 divided by 5 would be 9, so that means our new numerator should be 29, and then our denominator should be 200 divided by 5, which is 40. And I believe that that's the most that you can reduce this. 29, if I'm not mistaken, is a prime number, so that's the most that you would be able to reduce this one, and that would be your final answer. So we started with 0.725 as a decimal, and as a fraction in lowest terms, that would be represented by the fraction 29 over 40. Alright, so that's the basic idea. We'll do two more examples for decimals to fractions. I just want to point out a couple things. So the second example we'll do is, let's see, this time, I'm going to get rid of this now. This time we're going to do 0.0036. Alright, and we want to express that as a fraction. So to do that, you could do it the slightly more complicated way, but let's deal with the numerator first, since we know how to do that. That's more simple. We look at everything that's after the decimal point, and we've just got the number 36, right? We don't care about these extra zeros in front, so our numerator is just 36, right? I mean, you could put the extra zeros there, but it doesn't change the value, so might as well just write 36 up top. Now, if we look at it in what I consider to be the more complicated way, for our denominator, this is the tenths place, that's the hundredths place, that's the thousandths place, and that last digit, that's 6, is in the 10,000ths place. So that would tell us that our denominator should be 10,000. Now the other way that you could do it, and possibly the simpler way, is if you ignore all of that and you just count. We've got 1, 2, 3, 4 digits after the decimal point, so I should have 1, 2, 3, 4 zeros in my denominator after I throw down that 1. The thing that you have to be careful of is that notice that in the numerator we're ignoring these extra zeros because they don't change the value, the overall value of the number, but in the denominator we have to consider both of them. Even though they don't change anything upstairs, they're going to change something downstairs. If you ignore them, you'd get a denominator of 100, which is going to give you a really different fraction. So we have to include those when we're counting the digits after the decimal point to get our new denominator. Now both of those numbers are even, and they're also actually both divisible by 4. So let's go ahead and divide both of them by 4. So if we divide the numerator by 4, we'll get 36 divided by 4 is 9, and 10,000 divided by 4 is going to be 2,500. Now, if I'm not mistaken, 2,500 is not divisible by 3, so this is the most that we would be able to reduce this, and that would be your final answer. This 9 over 2,500 is your final answer. So that's kind of it. There's not really much more to it. Going from decimals to fractions, you take whatever's after the decimal point, make it your numerator. You take the total number of digits, throw that into a whole bunch of zeros in your denominator, and then you just reduce to lowest terms. Now we're going to do one more example, and it's still going to be decimals to fractions, but I'm just going to point out that this sort of applies going from fractions to decimals as well. So for this last one, we're going to do 3.017, and we're going to convert that into a fraction. Now, I want you to leave a little bit of a gap after the equal sign before you put that line. So, what I've been saying so far is you take the stuff that's after the decimal point and you throw that into your numerator, right? We've got the number 17 here, really, if we ignore that 0, so we can make our numerator a 17. Our denominator, if I do it the way I prefer, we've got 3 digits after the decimal point. That means we're going to have 3 zeros after our 1. And so our fraction should be 17 over 1,000. But what about this 3? So far I've kept saying, ignore everything that's before the decimal. We are only focused on after the decimal. Well, if you look at this decimal, this is telling you that you've got 3 complete, 3 complete pizzas, 3 complete units of whatever, and then you've got this little bit of extra stuff left over. Now, how do we express that as a fraction? A proper fraction means that you've got less than a complete piece, and this is most definitely not an improper fraction, but as a fraction you can express having some number of complete wholes and some fractional bits as a mixed number. So since we have 3 complete pieces, we just take that 3 and it becomes the whole number of our mixed number over here. And so we've got 3 comes from whatever's before the decimal, and then the fractional bit all comes from the stuff after the decimal. And so similarly, you could take this idea in reverse. If I gave you the fraction 3 and 17 over 1,000, then you know that you already have 3 complete pieces. So when you're writing this as a decimal, you know it's going to be 3 point something. We don't know what that something is, but we know it's going to be 3 point something because of this whole number that we have right here. And then to figure out that something, we would do 17 divided by 1,000. You could do the long division and get a decimal answer to stick on at the end there. So that's basically how it works, going from fractions to decimals and decimals to fractions. Sometimes you'll be dealing with quantities larger than 1. Obviously in this video we've focused mostly on quantities smaller than 1, right? We talked about 4/7 and 0.0036 and things like that. I've tried to show you all of the sort of curveballs that I can throw in your direction, like giving you extra zeros after the decimal point before the numbers that you care about. But it's really not overly complicated stuff. If you are finding that you're struggling with this, let me know. I will be more than happy to make another video on this stuff. The next lesson, if I'm not mistaken, is going to be on just sort of practice problems converting fractions to decimals and vice versa. And then after that we'll be having a test review. I might do some more practice examples in that test review, but that's basically it for fractions and decimals. So you guys will be getting a test. It'll be coming your way sometime reasonably soon. But yeah, just practice, use some fraction to decimal conversion. That is not on your assignment, but you can always, Google questions like that. converting fractions to decimals, converting decimals to fractions with answers so that you can check your work. But yeah, if you guys want more practice problems, or if you want me to give you a worksheet on this, just leave a comment, let me know somehow, get in touch with me, and I will see what I can do. But if you don't have any questions and you're understanding everything, then I will just see you guys in the next video. Have a good one.